We're going to look at graph transformations, and I'm starting by looking at some graphs in GeoGebra. So here I am in GeoGebra, and I'm going to start with the trigonometric function y equals sine x. So I'm looking at the input box at the bottom there, and I'm typing in y equals sine of brackets x. And then I'm going to tell it that I want it in degrees. So on my Mac keyboard, that's Control 0 for a degree sign, and Enter. And there's a nice sine curve. Now, what if I wanted to do the graph of y equals 2 sine x? So 2 times sine x. What does that look like? Y equals 2 sine brackets x degrees. And as you can see, everything's got twice as big. So in other words, it's stretched away from the x-axis by a factor of 2. So putting a number in front of the function stretches it by that factor away from the x-axis. So I'll get rid of that and think about what if I did the sine of 2x, y equals sine brackets 2x degrees. So instead of doing the function and then doubling it, what I'm doing is doubling the x first and then applying the function to it. What do you think that will do to the graph? Well, in fact, it does something in the horizontal plane instead of the vertical plane. So it does something in relation to the y-axis, and perhaps surprisingly, instead of stretching out in relation to the y-axis, it compresses it. So everything is squashed in towards the y-axis by a factor of 1 over 2. So it's squashed it so it's half as big in relation to the y-axis. Now let's look at some quadratic graphs, and I'll start with the basic quadratic function y equals x squared. So in the input box again, y equals x, and then on my Mac, Control 2 will give me a squared sign. And there's the graph of y equals x squared. Now, what do you think will happen if I do y equals x squared plus 3? Let's try that. Y equals x squared plus 3. And perhaps not surprisingly, because we've added 3 to everything, the whole graph shifts up by 3. And similarly, if we do y equals x squared minus 3, you get the same graph but shifted down by 3 units. But let's get rid of those and think about doing something to the x before we square it. So instead of y equals x squared, y equals brackets x plus 3 squared. Now, instead of doing something vertically, what happens is something changes horizontally, but perhaps surprisingly, that makes the graph shift to the left, so that instead of the vertex here being at 0, it's at minus 3. So even though it's a plus 3 in the function, the effect it has is to shift it to the left. And similarly, if we get rid of that and type in y equals x minus 3 squared, it actually shifts it to the right so that the vertex ends up at plus 3. Well, these properties help us to solve exam questions like this one. Sketch the graph of the function y equals x squared plus 6x plus 20 by rewriting it in another form. So let's think about x squared plus 6x plus 20. We're going to start by taking the coefficient of x, which is 6, the x number is 6, and we're going to halve it to get 3. We're then going to take that and square it to get 9, and then we're going to take that 9 and we're going to rewrite this 20 as the 9 plus 11. So instead of y equals 6x plus 20, we've rewritten it as y equals x squared plus 6x plus 9 plus 11. We've rewritten the 20 as 9 plus 11, and we got that 9 from the process I just described. Well, the point of that is that you end up with part of this expression, the x squared plus 6x plus 9, being a perfect square. You can write that bit as x plus 3 squared. So you get the number that goes in the bracket from half of the coefficient of x. So the coefficient of x was 6, and you halve it to get 3, and then x plus 3 goes in the bracket, and the 11's still there, so that whole expression can be rewritten as x plus 3 squared plus 11. Well, the point of that is that you can then take the basic graph of y equals x squared and apply some transformations to it. So if we started off with y equals x squared, then what would the graph of y equals x plus 3 squared look like? Well, as we saw before, that would have the effect of shifting it not to the right but actually to the left, so that it had a vertex at minus 3. And then the plus 11 would start to move the graph upwards by 11 units. So we ended up with something that looked the same as y equals x squared, but it was shifted 3 to the left and 11 up, so that it had a vertex at minus 3, 11. So here's some questions that you can try. It's all basically the same question, but with different numbers that cause the graph to shift in different directions. So the first one is you have to try to sketch the graph of y equals x squared plus 4x plus 1. Second one, you have to try and sketch the graph of y equals x squared minus 8x plus 10. And then x squared plus 6x plus 14, and then x squared minus 2x plus 3. And all of those you try to solve by rewriting them in the same way and figuring out how it takes the basic graph of y equals x squared and then shifts it left, right, or up and down.